Alrighty, so one more question to finish energy systems. Now we went over, we'll call it fast and slow glycolysis, but we went over slow glycolysis. Oh, probably should put it the other way. So technically, fast comes first because you use that energy first. Fast glycolysis. Now these are also other ways that they're known as. They're either known as fast glycolysis or anaerobic. Remember, many names for the same thing. Fast glycolysis or anaerobic, you give energy very, very, very fast. That's one. The other one is slow. Now, some people call it, you might see it called as slow glycolysis, which doesn't technically make sense because the glycolysis is a fast process. It's that very first process of taking glucose to pyruvate. Always happens. And remember, that is in the cell's cytosol. So I don't know why people call it slow glycolysis, but we'll just say the slow energy system, which is also called aerobic. Don't think of it as with oxygen, because as we just shown, they both involve glycolysis because you have to go through glycolysis to get to pyruvate in order to get to the Krebs cycle. So they both involve a system that does not involve energy. Anaerobic, slow, longer. Now these are two energy systems, so this is what we consider glycolysis. This is mostly either considered aerobic respiration or, mostly aerobic respiration. Aerobic respiration. The other system is something called the Atp Pcr system. Now this is like a very, very extremely fast energy system, whereas glycolysis, so we'll put some time frames on these. Glycolysis usually goes from 2 to 3 minutes of activity. So glycolysis supplies, fast glycolysis. The anaerobic system supplies enough energy for activity that lasts up to about 3 minutes. Then past that, then aerobic respiration takes over. Aerobic respiration is usually from 15 minutes on, well, we'll say from 3 to 15 minutes plus is aerobic respiration, whereas the ATP PCR system supplies you energy extremely fast. So the most explosive events involve ATP PCR. Now these events, the ATP, remember how I said that the body has usually a reserve energy in the system? That's what the ATP PCR system is. Now the ATP PCR system uses creatine or phosphocreatine and whatnot. That's what this is, phosphocreatine. Now the ATP PCR system is that reserve of ATP you have in your cell cytosol. This is in the cell cytosol just like glycolysis is. Now in the cell cytosol you have somewhat like, say you have 3 ATP molecules. You'd have more than 3, but to make it simple, say you have 3 ATP molecules chilling out in the cell cytosol. So you have glucose over here inside the cell cytosol also doing its own thing, but let's say we need ATP right away, or we have this reserve of ATP. So it makes sense obviously to use this ATP before we use glycolysis, breaking down to pyruvate, breaking down to lactic acid. So we use this ATP first. We use it extremely fast. Now the way ATP works is ATP by itself doesn't give us energy. It stands for adenosine triphosphate, so it has 3 phosphate groups. So something that's A, I'm not going to draw, and then you have a little phosphate, phosphate, phosphate. That's what it looks like. And when that third phosphate is cleaved off, this phosphate then is a free phosphate. This is hydrolysis. It's the combination of water, breaks it down, whatever. And then the phosphate goes and runs many other processes and forms of energy. But then what happens to this ATP is it forms something called ADP. ADP is not what we need in the body. It doesn't give us energy. We want ATP. Now say we use all 3 of these ATPs and we have 3 ADPs. Now then we'll be shit out of luck and we have no more energy. But luckily our body has prepared for that and we have a system called ATP. We have a molecule called PCR, phosphocreatine. It's essentially a phosphate attached to a creatine, and we need another phosphate in order to form back ATP. So what happens is the ADP takes that phosphate, and then you form an ATP. So the whole reaction or formula looks like you have PCR, which is phosphocreatine, plus an ADP molecule, which it finds, and it forms an ATP in your creatine. And that's the same thing that people supplement with, creatine, that I think builds muscle. So this whole process, say you have ATP on reserve in the cell, you begin an explosive activity, very intense. Instead of forming lactic acid first, you hit this first and you use this ATP, provides you energy extremely fast, have ADP, breaks it down, and you have to reform the ATP in order to keep that process running. And you have this phosphocreatine chilling out here. It's like, oh, hey, I'll give you phosphate. So it gives its phosphate and you form an ATP. Now you only have so much phosphocreatine. So say you run out of phosphocreatine and now phosphocreatine isn't there, so it's like the rate limiting factor, whatever, and then you can't form ATP anymore from the system. So when that happens, then your body will use glucose into aerobic respiration, you'll form lactic acid. Now, the ATP Pcr system only gives you enough energy to last up to 10 seconds of exercise. This whole process I just explained only lasts for about 10 seconds. So it gives you energy for about 10 seconds. So you can think about it how whenever you start exercising, you always first you use the ATP Pcr system because you have that in reserve, and then up to about 10 seconds. Different books say 5 to 10 to 15 seconds, but it's extremely fast. Now up to 30 seconds, no, that's a little stretching it. About 10 seconds is safe to say, up to about 10 seconds. And then you rely on fast glycolysis, which can go up to 3 minutes. So that would be like running an 800, which is a half mile on the track or something, which is still an explosive activity, but it doesn't last 10 seconds. And then you get into slow glycolysis, which is like running a 5K or a marathon, running a very long distance. So now we'll go over another system. What system do you think that will use the what activity do you think will rely mainly on ATP Pcr system? Well, that'll be any very explosive activity where you need energy right away. So that'll be mostly like gymnasts because they need energy right away, or they rely on their activities only last usually about 10 seconds. It's very explosive, whatever. So they need energy right for like only 10 seconds. So they rely on the ATP Pcr system. You also have pole vaulting, because that depends on energy extremely fast. The window of when they actually use energy is very simple. They're running, they put the pole on the ground, they vault, whatever. That pole process only takes like 2 seconds or 3 seconds. So they need energy extremely fast. So they rely on the ATP Pcr system. Another one will be like a 100-meter sprint. 100-meter sprint is only lasting like 10 seconds. You need, well, if you're world record speed, but it's only lasting like 10 seconds, but you need energy extremely fast, so you rely on the ATP Pcr system. You also use that as a softball pitch, you get it. Anything you need energy extremely fast, well, the duration that you need the energy is only like 2 seconds or 10 seconds long, you use ATP Pcr system. If the activity lasts up to about 3 minutes, like 800 meters, I don't know. Some people might run 100 meters in 3 minutes. I don't know. But if the activity you can justify only lasts up to 3 minutes, you rely on mostly fast glycolysis. That would be running 800 meters. It only lasts up to 3 minutes. Now, if the activity is a long duration that can last for a very long time, it'll be aerobic. That will be running a marathon, cycling, because you're cycling more than 3 minutes. Swimming, you're swimming more than 3 minutes. Anything that relies on energy for a long period of time is aerobic. If it lasts up to 3 minutes, it's anaerobic. If you need energy for a split second or 10 seconds, it's ATP Pcr system. Remember that.